So here we have an example that's not too different from our original 1 over x, where it's now 1 over x minus 2. But instead of plotting using a t-table like we did on that original, we want to use our knowledge of where the vertical and horizontal asymptotes are located and where any x or y intercepts might be found to generate a sketch of the graph. And so we're not going to plot out a whole bunch of points. We're instead going to find these locations and build our graph that way. So first of all, for the vertical asymptotes, if you'll recall, we find the vertical asymptotes at the values of x that make the denominator equal 0. So I'm going to take the denominator this time, x minus 2, and I'm going to set it equal to 0, and then I need to solve for x. Well, if I just add 2 to both sides, then I just get x equals 2. So that is the equation of our vertical asymptote. So on my graph, I'm going to go to x equals 2, and I'm going to go ahead and dot in a vertical line. So that is a line that our graph cannot cross. It's going to come really, really close to it, but it's not going to cross it. So that means our two branches of our graph are going to be on either side of this vertical asymptote. Now for the horizontal asymptote, that's going to be located depending on the value of the exponent of x in the numerator and the denominator. And so in this case, since we have no x in the numerator, but we do have an x in the denominator, that automatically means that y equals 0. The x-axis is going to be our vertical asymptote. Since the denominator has a higher exponent of x, that means the x-axis is going to be our horizontal asymptote. So the line that our graph is going to approach but not cross is going to be the x-axis in this case, so y equals 0. And so now to generate the graph, it can be helpful to just generally create a point or two that can help us figure out where the branches of the graph are located. We know, generally speaking, we're going to have either a branch up here or down here. We can't have both because then we wouldn't have a function. It would fail the vertical line test. So we just really need to figure out whether the branch on this side of the graph is above or below the x-axis. So the way we can do that is just plugging in a point that's somewhere to the right of the vertical asymptote. And so since the vertical asymptote is here at x equals 2, why don't we plug in 3 for x and see what we get. So if we plug in 3 for x, f of 3, meaning I'm plugging in 3 for x, so I get 3 minus 2 in the bottom, so I get 1 over 1, so I get an output of 1. So that means when I plug in 3 for x, I get an output of 1, so roughly right there. And so that alone is enough for me to be able to sketch that branch of the graph, because I know that I'm not going to cross through either of these asymptotes. I know that the farther out I go for x, the bigger numbers I plug in for x into the denominator, the farther this way I go, the closer to the x-axis my graph is going to go. And then likewise, I have this vertical line that my graph can't cross, so as I inch closer to the vertical asymptote, there's only one way I can go, which is up, because the graph can't cross through that horizontal asymptote that's below it. So that means we've just through generating one point and knowing where the asymptotes are located, we know this part of the graph. And then we just need to do the same thing for the other side. I need to know whether the other branch is somewhere up here above the horizontal asymptote or somewhere down here below. And so I'm going to do that by plugging in a number somewhere to the left of our vertical asymptote. So let's say we plugged in 1. So if I plug in 1 for x, I get 1 over 1 minus 2, which is 1 over negative 1, which is negative 1. So I get an output of negative 1. So when I plugged in 1 for x, I got a negative 1 output for y. And so now I know where the branch is on this side. It's below the horizontal asymptote down in this lower region of the graph. I know that I can't cross through the horizontal asymptote or the vertical asymptote, so I know my graph is going to be shooting downwards. It's the only direction that this graph can go as it gets closer to that vertical asymptote. And I know my graph is going to extend this way, getting closer and closer to that x-axis without ever actually crossing it. So at this point, I have a really good sketch of my graph. I do have a few things I still need to find. I want to know what the x and y intercepts are. So again, from the instructions that we had before, we know the x-intercept is located at any value that makes the numerator equal 0. But since the numerator doesn't have a variable in it, and we have a horizontal asymptote running along the x-axis, there's not going to be an x-intercept. We don't have one. For the y-intercept, we just plug in 0 for x and see what we get. So if I plug in 0 in place of x, I go 1 over 0 minus 2. Well, that's 1 over negative 2, or negative 1/2. So I can write it either as just a number, or I can say 0 comma negative 1/2. And so that looks about right, confirms what we did with our sketch just a little bit ago. So we've got this y-intercept here. And then the last question we have to address is the domain and range. So domain is a question of what x values we're allowed to plug in. Well, there's only one number that we can't plug in for x. That's the location of this vertical asymptote. It's the number that makes the denominator equal 0. And so that number is going to be x equals 2. So we can say for our domain, it's all real numbers because it's everything else. It's just not x equal 2. So we say x cannot equal 2. And then for the range, that's a question of what y values this graph includes. So for this graph, it goes up forever and ever. It goes down forever and ever. So we might want to say it's all real numbers, but we do have this horizontal line that our graph never makes contact with, never touches. So we have one value that's excluded. So just like with the domain, x cannot equal 2. For the range, in this case, it's all real numbers, but y can't equal 0 because the graph never ever goes through the x-axis. So this is how we can generate these graphs, by finding where these vertical and horizontal asymptotes are located, and then just plugging in a single number on either side of our vertical asymptote to just get an idea as to where the graph is located, and then using our understanding of how the graph interacts with these asymptotes to draw the sketches. And then we just have these additional features, the x and y intercepts, and domain and range, that we can solve for as well.